Good morning everybody. This is our fourth video of the chapter 2 metals and non-metals. In the previous videos we have studied a lot about properties of metals and non-metals, their reactions, their different compounds. Now in today's video we will discuss about how do metals and non-metals react. When a metal or a non-metal react, each or every element react to complete their octet. 8 electron in its outermost shell or valence shell or duplicate. 2 electrons in their outermost shell or valence shell. To occupy this duplicate or octet, an element, a metal or a non-metal react. So, how do they react and what are the bonding between them? To understand these things, we need to know chemical bonding. First of all, what is its definition? Chemical bonding. What is chemical bonding? Chemical bond is a force, is an attractive force. Which holds two atoms together. Atoms, when loses electrons, it becomes positive ions, and when gains electrons, it becomes negative ions. So how do they react? To know the reaction between them, how their structures are, we must understand the chemical bonding between them. Like, there are 3 types of chemical bonding. 3 types of chemical bonding. First is electrovalent bond, or called ionic bond. Second is covalent bond, and third is coordinate bond. Coordinate bond. Let's understand one by one. First is electrovalent bond. Electrovalent bond is formed by the transfer of electrons. Electrovalent bond is formed by transfer of electrons. Covalent bond is formed by sharing of electrons. And coordinate bond is formed by sharing of lone pair of electrons. In next chapter, we will discuss about covalent bond and coordinate bond. In this chapter, let's discuss only electrovalent bond. What is an electrovalent bond? It is formed by the transfer of electron. For example, it generally occurs between metal and non-metals. For example, if we consider sodium chloride, how they are formed, or if we consider sodium oxide, how they are formed. They are formed like sodium, its configuration is 281, when loses one electron, minus one electron to form Na plus, and chlorine, its configuration is 287, when gains one electron it forms Cl minus. So to denote this loss of gain of electrons, we use Lewis formula, Lewis dot structure. Lewis is a scientist who worked on chemical bonding, how chemical elements react and what are their valencies, etc. So Lewis dot structure or Lewis dot formula, or generally it is called electron dot structure. To show the formation of sodium chloride by electron dot structure or Lewis dot structure, we must write the outermost electron at sodium. Like sodium, if we consider what is the Lewis dot structure of sodium, then it is sodium dot, and if it is chlorine, then there are 7 valence electrons. So write like this: 1, 2, 3, 4, 5, 6, 7. And how the two combines? Let's start. Sodium. By losing one electron, sodium forms sodium plus. This is, and chlorine. The structure of chlorine is like this: 2, 4, 6 and 1, 7. Now, to combine with chlorine, sodium need to transfer this electron to chlorine. The transfer of electron is denoted by the arrow like this. Now sodium becomes Na plus and chlorine now becomes, by taking 1 electrons, it has 8 electrons. So write chlorine like this: chlorine minus. This is the formation of sodium chloride, or we can say that Lewis dot structure of sodium chloride. So the formula of magnesium chloride is MgCl2. Magnesium needs to connect with 2 chlorine because magnesium has tendency to lose 2 electrons. First 1 electron to one chlorine and another to next chlorine. So this is the formation of magnesium chloride. These ionic compounds are generally formed by the combination of metal and non-metal, with magnesium chloride with sodium chloride. What about aluminum chloride or aluminum oxide? Aluminum, so you must remember that aluminum oxide or chloride, it has both covalent, both first ionic and covalent character. Because when we go to from the left to right of the periodic table, it is sodium, magnesium, aluminum. So when we go to from group 1 to group 3, here it is ionic character in group 1, ionic character in group 2, but there is partial ionic and partial covalent character. Due to their difference in electronegativity with the non-metals, the difference of electronegativity of aluminium is less than that of sodium and magnesium, and the size of the aluminium is more than that of sodium and magnesium, so the bond formation is partial ionic or partial covalent. So practice to form the Lewis dot structure. There is a question that draw Lewis dot structure or electron dot structure of the following compound. First is calcium oxide, second is potassium oxide, third is calcium chloride, and fourth is potassium chloride. So draw the Lewis dot structure of these 4 compounds and submit me in your class. Chloride. If we consider sodium oxide, the steps must be noted. Sodium oxide. First, you must write sodium, electronic configuration of sodium and oxygen and its electronic configuration. Then, sodium has only 1 electron and oxygen has 6 electrons. 1, 2, 3, 4, 5, 6. So, oxygen, this sodium gives 1 electron to this oxygen, but to satisfy, to complete this their octet, oxygen need 2 sodium. So next sodium is like this, and this sodium also transfer 1 electron to this oxygen. Now sodium becomes sodium plus, and oxygen becomes 1, 2, 3, 4, 5, 6, 7, 8. You must write all 8 electrons with oxygen with 2 minus charge. Now they becomes sodium oxide by forming bond with these two. It becomes sodium oxide. Next example is magnesium chloride and magnesium oxide. First consider magnesium oxide because it is easier than magnesium chloride. So first of all you must write the electronic configuration of magnesium. It is 2A2. Magnesium has 12 electrons, so its configuration is 2A2, and oxygen then is 2,6. For combining these two, magnesium, outermost of cell of magnesium contains 2 electrons and oxygen contains 6 electrons. Leave a vacant space in front of magnesium so that you can transfer these 2 electrons to this oxygen. Magnesium oxide. Now magnesium becomes magnesium 2 plus and oxygen becomes with taking 2 electrons from here. These 2 electrons of magnesium. So magnesium now becomes oxygen now becomes 2 minus. The formation of bond is with magnesium oxide. Formation of MgO. Next is magnesium chloride. Magnesium chloride. The configuration of magnesium is known here, 282, and configuration of chlorine is 287. You must write the configuration. By writing the configuration, we can understand that the valence electron or outermost shell contains 2 in magnesium and 7 in chlorine. So, when magnesium loses, magnesium outermost shell contains 2. So, this is the Lewis dot structure of magnesium, and for chlorine 1, 2, 3, 4, 5, 6 and 7. 1 electron of magnesium is transferred to the chlorine. What about this electron? This electron needs another atom of chlorine. So, you can write here like this, another chlorine, and transfer this electron to this chlorine. Transfer this electron to this chlorine. Now, magnesium becomes magnesium 2 plus, and chlorine, how would you write this chlorine? So, write like this with this 2 chlorine, 2 Cl minus. You can write it here or you can write it here also. This or two. These two are correct. So, this is the formation of magnesium chloride. Our next topic is properties of ionic compound. Ionic compounds are formed by the electrostatic force of attraction. Means these sodium and chlorine, sodium plus and chlorine minus, chloride minus, these two are attracted towards their self due to this electrostatic force of attraction. So, ionic compound is formed by strong electrostatic force of attraction. So, the first property of ionic compound is they are brittle solids. Brittle solids. Why they are brittle solids? Because, why they are brittle solids? Because they have, due to strong electrostatic force of attraction. Force of attraction. You must write in your notes all these properties and all the things I am describing here. You must write in your notes and submit your notes copy also. Second thing, their melting point, because they have a strong force of attraction. So, their melting point and boiling point are also very high. So, their melting and boiling points are very high. Next is they are soluble in their solubility. The next is solubility. They are soluble in ionic solvent. Soluble in aqueous and ionic solvent, but insoluble in organic solvent. Organic solvents are like petrol, diesel, alcohol, ether, ketone, etc. Fourth one is they conducts electricity. They conducts electricity in molten state. Molten state means first it melts and then it at its melting point. For example, if you want to conduct electricity with sodium chloride, first you melt it at its melting point and then they conduct electricity, molten or in aqueous solution. Molten and in aqueous solution. And the fifth one is they are non-directional. Directional. That means if you want to form a compound like magnesium chloride or magnesium chloride, then you can write magnesium chloride like this. This is magnesium chloride, and you can also use this type of bond formation with magnesium chloride. These compounds are non-directional, not a fixed direction.